Hello everyone. We're going to do some examples of solving word problems using scientific notation. So let's look at the first problem. A certain social media company processes about 990 billion likes per year. If the company has approximately 8.9 times 10 to the 8th users of social media, about how many likes is each user responsible per year? As we've done the previous lesson, we identified what operation we will be using, and it is division. And that's because we're finding how many likes for each individual user. We are grouping them. So what we need to do is we need to take all of the likes and divide it by the number of users, so we know how many likes per person it is, right? Because we want the number of likes per people. So if we take 990 billion, so if we look at that, 990 billion is 990 times 10 to the 9th, right? And we can use that in our equation. That's not perfect scientific notation, but it will do for now. 990 times 10 to the 9th, all divided by 8.9 times 10 to the 8th. This is our numeric expression. And what we could do is we could type that into our scientific calculator, or we can use our lovely friend Google by using the asterisk as multiplication and the little caret above the 6 as our exponent. So if we type this in, make sure you need to use parentheses around the numbers. If there are no parentheses, it will not be calculated correctly because of the order of operations. When we type this into Google, we get a number that looks like 1112.3595505. So we have this really long decimal, but we have about 1,112 likes per person. So we're going to estimate this because it says about. So we're going to round and estimate. So our answer is 1,112 likes per person. If we want to write that in scientific notation, it would be 1.112 times 10 to the 3rd, right? Because we were moving backwards, 1, 2, 3, and we have 1.112 times 10 to the 3rd. So the number, so we're going to answer in a complete sentence, the number of likes per person in a year is 1,112. We're going to write about. Great. Let's look at number 3. Federal states that the average household in January 2013 had $7,122 in credit and debt. About how many times greater is the U.S. national debt, which is about 1.6755 times 10 to the 3rd. So how many times greater? So that we're going to take the U.S. debt and divide it by the credit card debt, right? Because we want to know how many times greater, and how many times means division. So we'll take that U.S. debt, which is 1.6755 times 10 to the 13th, all divided by, that whole thing in parentheses divided by 7,122. Now we can leave it just like that. We don't have to put it in scientific notation. If we wanted to put that in scientific notation, it would look something like this. If we wanted to make that number, we would move it to the left because it's a really large number, and we would have 7.122 times 10 to the 3rd, and that's how we would divide it, right? If you're writing this in on the computer, in Google, you would use the asterisk as multiplication, the little star above the 8, then you would write 10, and then you would have the caret above the 6, 13. So again, I'm just rewriting this as you would on the laptop. Use your asterisk, the 10, the caret, the 3, and that's how you would type it in. So if we type this into Google right now, 1.6755 asterisk 10 exclamation exponent 13. Remember, you need your parentheses. And the division side is just the backward slash. That's all you really need. And then we have this extremely long number. So we have 2, 3, 5, 2, 5, 6, 9, 5, 0, 2.95. So that's how many times greater the U.S. national debt is compared to the a household credit card debt. We can rewrite this in scientific notation if we want. Remember, when we write a really large number in scientific notation, we move to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9. So now our new number is 2.35256950295 times 10 to the 9th. And then our answer in a complete sentence is the U.S. national debt is 2.35256950295 times 10 to the 9th times greater than the household credit card debt. All right, let's do a couple more. Here are the masses of the inner planets of the solar system. So here we want the total masses. That means we're just going to add them all up. And again, you're going to put them all in parentheses when you add them, but you're going to use the same tools that you do on the computer for the other ones as you would here. Running out of room. And then we would add all that up. For subtraction, it would be the same thing. So we want to know how much larger Earth's mass is compared to Mercury's. So that would be Earth minus Mercury. And we would have 5, again, in parentheses, 0.9722 times 10 to the 24th minus 3.3022 times 10 to the 23rd. That's it. I'm not going to solve those because we kind of went through how you would really just need to use your calculator or computer for those. This is how you would set it up. Again, it's really about the keywords and the context of the question. And that's it for today. Have a wonderful day, and see you all soon.